Okay, welcome everyone. This is actually the last regular webinar of the class. So, and it's only kind of regular. It's not even a regular webinar. The last one was Wednesday. And in fact, I don't even have a list of items to talk about in terms of new material. And hopefully y'all know why I don't have a list of items to talk about. Any thoughts? Yeah, it's review day because there are no items. Okay, it's not because I, slacked off and, didn't come up with a list. But there are no items, but I do want to talk a little bit about upcoming stuff. I always like to go through the calendar. And I thought I might as well do it on this screen. So in terms of upcoming stuff, what we have is today, we're going to pretty much, I'll answer questions on the homework, of course. And then I'll talk about the final. I've mostly written the final exam. I haven't taken it yet, so haven't decided whether it's, all in perfect shape or not, but it's pretty much written. And so that's what we'll do today, and we'll see, I'm going to take questions mostly. So it's going to be mostly Q&A today. That's kind of the idea. And then on Monday, what's going on Monday?
Presentations.
Yep, presentation. So really important that you've got your topic set, because I don't think everyone wrote their topic down in the last chat. I think there were some of you, but not all of you. And it's important that you don't overlap, because I will zap you if you overlap. So you want to make sure that you have different topics, and you can pop in the chat box. That's fine. If you haven't told everyone your topic yet, and make sure that you're not using the same topic that someone else is making, because we don't want the same thing said twice in a row. That'd be kind of bad. So you do need to have different topics, and there's plenty of topics to choose from. And so on Monday, that's what we'll do. I'm going to do not that much talking, other than saying, all right, next is this group. And in fact, Jason already picked his group as the first group because he's got to work. And he's going to give his presentation and he has to go to work. But otherwise, everyone's got to go eventually. So just let you know, a reminder that it's a 20-minute presentation. So you have 20 minutes to present. And then after the 20 minutes of presenting, Q&A time. So that's when you ask each other questions about, interesting things about your project or something you may not have understood, or elaboration, whatever it might be. So ask questions. And that will be Monday. Okay, so we got machine learning, Jordan, Jason, and Jesus. I know there was a physics, quantum physics 1. Trying to remember what the others were, but I don't think there were 4 written. So hopefully you can all write them down, put in the chat box. So that'll be Monday. So the bad news is I never heard back from my dean. So I don't think we're having our Wednesday live face-to-face group, because I need to get permission and I didn't get permission. So don't get mad at me on that one. I sent multiple emails, but I think the dean's very busy because the other dean's on maternity leave. So that we have one dean doing everything. So I think he's just too busy. So I apologize if I got your hopes up for Wednesday, but I don't think we can do it because it's one of those I have to get permission because of COVID and all that. So I will be in my office hours all week though. So I'm office hours Monday, Tuesday, Wednesday, Thursday, and Friday. So that'll happen. And in fact, maybe I'll pop in and share the syllabus so we can talk about what is coming and what to expect and all the different things. Just a minute. Okay, so here's the syllabus again. So I want to first remind you that you have presentation. Presentation is 10% of the grade. Take it seriously. Okay, so however many points it says a presentation is, it'll be a percent anyway, so it doesn't matter. So it's your 10% of your course grade will be the presentation. Just let you know that. And that is, again, on Monday, so take it very seriously. It's like half an exam in terms of the points. So hopefully you'll all do great. That's what I'd like to see. So if you prepare a lot, then you'll do great. And I want to remind you that it'll be on Zoom. And you'll be able to share your screen, or at least my recommendation is one person in your partnership shares the screen. If you go back and forth on sharing screen, it's kind of messy tech-wise. So it's better to have one of you sharing the screen, and then you can both talk about what's being shared. But that seems to work better than going back and forth with sharing screens, if that makes sense. The exam is 35% of your grade. So that's a big chunk of your grade. There's a lot of grade left in this class. We got, 45% of the grade left for next week. So a big part of the grade is next week's work. Okay, any questions about kind of the structure of the class in terms of points and all that? Notice also, and I go by what the schedule in the at the college says, and it says I have to give the final exam from 12 to 2. So it's not the normal time a week from today. So just make sure that you're ready for that. It's not 1 o'clock, it's 12 o'clock. So that's when the final will be. Okay. So that's just what's coming, and it is, again, really important that you get that ready, get it ready, and get ready for the final. The other thing is what I decided to do is I posted last year's final exam as a practice final. Okay, and I just did that yesterday, I think, or the day before, something like that. So if you click on that, that'll take you to last year's final exam. Okay, I purposely don't have a key written because it's good practice to be able to do problems without being able to see the answer right away. So that's why I purposely didn't put a key. If you want to do problems with a key, then you can always go ahead and go to the book problems, because a lot of them are in the back of the book. But this one doesn't have a key. Any questions about what's coming up on Monday and Friday? Any questions? Okay, and I just want to let you know, I have office hours today, of course. I don't officially have office hours on the weekend because it's the weekend, but I'll be checking my email a lot, back and forth. I think I might ski a little bit tomorrow, but other than that, I don't have too many plans. So if you have questions about the presentation or the final, feel free to ask, and I'll be happy to help you out. We could even Zoom together if you really want, if the timing works for both of us. So any questions? Again, this is a good time to ask questions. Any questions? Okay, so if there's no questions, what I thought we would do, in just a second, let me get it set up, because we do have homework today. And I thought I could answer questions that you might have on the homework assignment, because that is due. 9.9, number 4. So let me go find it. And I got to share the desktop so we can get to it. That one. Okay, so here's 9.9, number 4. Let me hit enter a few times. Okay, so number 4 says the matrix for the linear transformation T in the standard basis is given by 1, negative 1, 3, 1. Suppose you instead want a basis that puts the conic x squared plus 10xy plus y squared equals negative 1 in standard form. And that is x squared over a squared plus y squared over b squared equals 1, or x squared over a squared minus y squared over b squared equals 1. Find the matrix representation with respect to this basis. Okay. So do you understand what the question is asking for, Ralph? Yeah, it's got to be ellipse or hyperbola. We don't know until we're done. So the idea is we need to change the basis. We need to find the basis to change it to, because we have this linear transformation. We need to change the basis so we have a linear transformation that makes it a nice conic instead of a rotated conic. So do you remember how to do that? It's been a while. What's the first step?
Find eigenvalues.
Yeah, find the eigenvalues. So let's do that. So what I can do, actually, I don't need that. I need to insert an equation. So if you remember, there was an equation for the eigen values. And in particular, there's an equation for the characteristic polynomial. And the way that works, might as well use the right letters. So I got to get to them. Is we have lambda squared. And then what's the next piece? Minus
the trace of A.
Yeah, and that's 2. 1 plus 1 is 2. 2 lambda. And then what's after that?
Plus the determinant of A.
Yeah, the determinant. And the determinant is 1 times 1 minus negative 1 times 3. And that is 4. Any questions on that? Does that factor, by the way? Hopefully you can all look at it within 10 seconds. No? Does that factor? The answer is no. There are no two numbers that multiplied, two nice numbers that multiply to 4 and add to negative 2. That's not going to happen. And in fact, I could look at b squared minus 4ac and realize I'm going to get a negative value. So that means we're going to have complex eigenvalues, but that's okay. So let's lambda is equal to, and use a good old quadratic formula. And that's going to be negative b, which is 2, and then plus or minus the square root of b squared minus 4ac. So b squared is 4, 4ac is 16. So I get the square root of negative 16. Sorry, negative 12. All over 2. Any questions so far? Okay, and that simplifies somewhat nicely. That's 1 plus or minus the square root of 3. I. Right? Because 12 is 4 times 3. You pull the 4 out as a 2. All the 2's cancel. And that gives you 1 plus or minus the square root of 3i. Any questions so far? Okay, so those are our eigenvalues. What do we get next?
Find the eigenvectors.
Yeah, so next we find the eigenvectors, okay? So to find the eigenvectors, what do? We plug in a minus lambda I. So let's grab this matrix and make an adjustment to it. So now what I'm going to do is I'm going to subtract lambda from the first component. And notice 1 minus 1 plus or minus root 3i is just root 3i. Any questions on that? And then we still have the -1. And the good news is I don't care about the bottom row because that's going to RREF to zeros. Anyone lost on that? Okay, what's next?
To find the null space of that.
Yeah, and the nice thing is it's pretty easy because I can let x equal 1 and then y equals root 3i. So that tells us, let's write this out. That tells us our v sub 1 plus or minus 1. We did a 1 plus 3i. Is that 1 plus or 1 minus? Let me look at this. That was 1 minus 3i. Was equal to, and now we're going to have, again, we're going to let x equal 1, and then y will be equal to root 3i. Any questions on that? Have I lost you?
To get the next one, it would just be a negative root 3i, right?
Exactly. Exactly. There's no reason to go and do all the work when we can use a big theorem that says that the eigenvector corresponding to the conjugate of the eigenvalue is the conjugate of the original eigenvector. So we do exactly the same thing, and I'm going to copy and paste. It is much easier. Put a comma in. And we could say for 1 plus 3i, you get 1 comma negative root 3i. Any questions on that? Okay. Okay, and we want the matrix representation for t with respect to this basis. Is that clear? So what do we do now? Any thoughts?
Form the basis with the eigenvectors.
Yeah, form the, not base, for the matrix, right? Is that what you said? If not, just say yes, that's what I said. Yeah, we form the matrix with the eigenvectors. Okay. And I am going to just, leave it as the easy way of writing it. So what I now have is we have 1 root 3i See if it lets me do this. That's here. Yeah, let me do it. So that's the first one. The second one is going to be 1 negative root 3i. And then we're going to have the matrix. Oops. So now we're going to put the matrix in with the eigenvector, with the eigenvalues. And the first one was 1 minus root 3i. And we're talking diagonal matrix. So those guys are zeros. And the second is 1 plus 3i, root 3i. I think I lost the root. Just a minute. Yeah, I lost root all over the place. There's a root there. Did it work? What just happened? I see what the problem is. Get those roots in. And then we're going to have the same matrix, but there's going to be an issue. What do we have to do? So that's not quite it. There's one last little thing I have to write down. What is that? Because that's not quite the answer. It's not right. So what do I have to do?
Transpose.
Close, except this is not, I didn't make this unit, so just inverse. Transpose works if you have an orthogonal matrix, but this is, I decided not to make it unit. I could have, because what, one, oh, it would have been nice. Maybe if you want, we can make it a 1/2 and root 3 over 2. And then it's nice and unit. So make them over 2s. And then I could do transpose. Any questions on that? Any questions? Okay, so again, and that's enough. I mean, if you wanted to like pop in a symbol lab and get the matrix by multiplying those 3, you can do that. Does that make total sense, though? Questions? Just a note, what does this matrix do? So what does it geometrically do?
Rotation.
Yeah, it's going to be a rotation. Okay, but it's got an I in there, so I think we don't even want to talk about it. Just gave you a little warning. Any questions on this question? Okay, are there other questions? Okay, if they're not, we can start talking about the exam. And again, today's a different day. I don't have like a list of topics because there are no topics to talk about today. It's just things that we're going to be doing in the next week. So what I'm going to do is I'm going to let you know that we have the exam. I'm going to ask you to tell me what's going to be on the exam because I bet you know. So maybe you can start putting in the chat box some things that you think are going to be on the exam.
Eigenvalues and vectors.
Mm-hmm. So let me write on exam. Yep. Yep. And again, my guess, I mean, you guys are the top students in the whole college. You're going to be able to figure out what's on this exam. I don't think I have to tell you, but I think it's a good idea for us as you as a group to kind of write it out. To me, I don't know if I mentioned it, I probably have, that was the way I always studied for tests is I would write an exam that I thought an instructor might write and then do problems. And I work with a friend and my friend would do it and we'd do each other's exam. And that was a nice way of getting ready. And there were times when I actually had the exact problem, kind of freaky, like the numbers were even the same. So you're at the level which you can do that. So let's see what else. What else is gonna be in the exam? The exam is not just one question, by the way. Yeah, linear transformation. Linear independence. Okay, what else? Let's kind of go through the main stuff. There are others.
Change of basis.
Change of basis. Okay, I'm going to put proofs because that's kind of towards the end. There are going to be a group of proofs that you have to do for sure. So what else? We've done more than this. Kernel and image, good. And I'm going to write along with kernel and image, what's the one word if the kernel is 0 and the image is the whole range? That's all part of kernel and image.
Onto and one-to-one.
Okay, onto one-to-one are important. Wasn't what I was thinking of. Yeah, isomorphism. Onto one-to-one, because these all go together. Do you agree? And isomorphism. Okay, so that's kind of a all one topic, basically. Okay, nullity and rank. Okay, what else? You're definitely missing one major topic that we've had very recently. And some other big ones too that we haven't, we've talked about, but haven't had a whole section on it. Yeah, vector spaces. And I'm going to write and subspaces. Okay, let me also write down what's a word that kind of goes with linear independence. It's not the same thing, but it's kind of done always at the same kind of time within one step. Yeah, span. Okay, so span is definitely a major topic that we have had. What else?
RREF.
Okay, RREF. I don't know if that's its own topic, but you certainly need to know how to RREF to be able to do like everything on the list. Do you agree? Yeah, try applications. Okay. And there's a lot of kind of applications. They're not major topics, but I think I'm putting one application on your exam. So there isn't the application problem. I'm not going to tell you which one it is because I want you to know them all. Okay. So those are the main topics. There's one more that we did for over and over and over again throughout the first, I'd say 70% of the class. Let's see, ready state vector. I think you mean steady state vector. And orthogonality. Think about orthogonality. Okay. That kind of goes with the eigenvalues and eigenvectors typically. And the steady state vector. Steady state vector is kind of an application. I think there was like 5 or 6. There's one main thing we spent for weeks and weeks. We kept doing it. 4 letters. That's a hint.
TFAE.
Yeah, TFE. Okay, that's pretty much the course. I do want to give you a heads up, and that is if I asked a whole question for each of these, what would happen?
We will finish.
Yeah, you'd run out of time. So don't get mad at me. Don't get mad at me if your favorite thing isn't on the exam, because I can't put everything on the exam because the exam would be too long. Okay. And I see bouncing reactions, conics, Markov matrices, Fibonacci numbers. Yeah, I just called that applications. Okay, so there's a lot of different applications. And
yeah, I meant like, could we go over the major applications that we learned throughout the course, like in a little bit more detail? Just so we know which ones.
Or what I want to do is not go over them. I'm going to give you examples, and I'm going to let you work on them, and then we'll do them. I think that's best for reviewing for a test. Not watching me is not as good as seeing if you remember how to do it yourself. Okay. So that's what the test is about. And I'm going to put one more in there. So proofs, I'm going to write and you should all know me well enough that you know what do I put in all my tests?
True and false.
Yeah. Yeah, and the true false questions. Okay, so that is going to be on the test. There are a lot of proofs and true falses. And for this class, true false is a proofs question. Okay, because if it's true, you got to prove it. If it's false, you got to find an example. Any questions at all on what to expect? Okay, just a note, it's going to be just like the other exams. You're going to have 2 hours to do it. It's going to be, just before the time, before noon on Friday, I will put it into Canvas, and then you'll be able to access it. So that's going to happen at noon. And then you have 2 hours, and then you take a picture of it with your camera, smartphone camera probably, or whatever you've got. And then you upload it onto Canvas. So it's going to be the same. Again, we're in a weird case where we can't take a face-to-face exam. I think that's a lot better if we could, but we can't. So we're going to do what we can do. Okay, any questions at all on the format of the exam before we start doing examples? Any questions? Again, there shouldn't be any surprises format-wise because you've already had 2 of my exams on, in this COVID times. Any questions? It's been a year now. I don't know if you realize, but a year ago I think that's when we started being online, like a year and a few days. So we're 1 year into it. Next year, we will not be doing this online.
Would diagonalization fall under orthogonality and eigenvalues and eigenvectors?
Yeah, I call that eigenvalues and eigenvectors because the whole point of diagonalization is you find the eigenvalues, you find the eigenvectors, and you just write it down as a matrix. So I call that eigenvalues and eigenvectors. Don't you think that that's really that topic?
Yeah.
Yeah, that's all kind of in that. There's lots of special cases of all kinds of things, but these are the, what I've listed, that's the main stuff. Okay. And orthogonality includes like Gram-Schmidt too. Remember, that wasn't about eigenvalues and eigenvectors, just a note. So I can do a an application question if you want, but you got to let me know which one, as in what topic you'd like to see, because I don't think I have time to do every single type of application problem. If you wanted me to do one.
Could we do a balancing a chemical reaction equation?
Okay. Those are actually a bit hard for me to come up with off the top of my head, but I'll do my best. Yeah, so whenever, like when that was on exam 1, I went online and I found, I think I typed in difficult to balance equations, something like that. Maybe I'll do that just for fun. We can do that together. So let's do that. And yeah, I just type in difficult and it knows I mean chemical balance because I typed that a bunch to look for your question. Let me do one that I didn't use. Let's see if I can find a good one. 49 chemical equations to balance. There's got to be one that had a worksheet, it said. All right. Yeah, powers is also an application. Okay. How about sodium bromide plus calcium fluoride equals sodium fluoride plus calcium bromide. So I know you can't see that, but if I like that, I think you can. I think that got big for you, right? So do number 20. Give that a shot. Let's see if you can use, and you got to use linear algebra. That's a requirement. In other words, no guess and check. I have no idea if this is hard, but doesn't look too bad. But you have to do it with matrices. So let me write it down so I can put it on the Word document. So we have sodium bromide, number 20. Maybe I should have chosen 21, but that's okay. It's the whole idea. Plus calcium fluoride goes to sodium fluoride plus calcium bromide. And let me type that in. So you should be working on it. Hopefully you're getting it. And again, I want to see a matrix. Okay. Or you should have a matrix. Okay, so here's on the Word document. Was it NF or NAF? Just a minute. NAF. Yeah, it's not nitrogen, it's sodium. So I'll just give you another minute or two, and it shouldn't take too long to do this one. And if I give you on the test, I'll probably give you a harder one. But the point is, once you know how to turn it into a matrix, it should be pretty easy. And put in the chat box when you think you got it. And just let you know, if this were on the test, it's definitely a with Proctorio. I mean, with computer problem. You'll have one problem that's without computer, and all the rest is with computer, just like the other tests. And this is definitely with. Okay, so we got one try at it. Oh, good. We got two people say it. So let's get the matrix. That's the important thing. The way you do this is you're going to write A times, good, sodium bromide plus B times calcium fluoride plus, it goes to C times sodium fluoride plus D times calcium bromide. So once we have that, now we're ready to think of this as a matrix. And the matrix, remember, are going to be the coefficients of the equations. Okay, what are the dimensions of the matrix?
It's going to be a 4x4.
Yeah, it's going to be 4 by 4 because we have an A, B, C, and a D. Sodium, bromide, cal, yeah, 4 by 4. Just double checking. Yeah, one more try. Okay. So the first thing is we can look at sodium. I'm just going to read from left to right. You look at sodium and what are the coefficients? So if you look at sodium, then what equation do you have? You have A times, all right, so you have A times 1 plus 0 times B, there's no sodiums in it, goes to C times 1 plus 0 times D. Any questions on that? So, so that means that our first coefficient will be 1 for the A. We're looking at the sodiums now. Second will be 0 for the B. Third will be -1. And fourth will be 0. Again, stop me if you're not understanding. Then let's go to bromide. There's 1 for the sodium bromides. That's the A. Then nothing for the next one. And then nothing for the third one. And then for the D, it's going to be -1. -2, sorry. Because we have a Br2 there. Then we go to the C's, the chloride, and that's going to be a 0, 1. And then 0, and 1, negative 1. And then for the fluorides, you're going to have a 0, and then a 1, 2, and then you're going to have a negative 1, and then you're going to have a 0. Any questions on the matrix? Okay, what do you do next?
Do we just REF it?
You could REF, but our REF is a lot easier. I mean, if you're using a computer, REF and RREF one's not harder than the other. Do you agree? For a 4x4?
Yeah.
And our REF makes it easier to answer at the end. Okay. So let me ask you, anyone RREF this? Because I could do this, but I'd rather just, trust you guys that you did it right using the computer. What'd you get when you RREF'd it? What'd you get for the first row?
1, 0, 0, negative 2.
Okay, 1, 0, 0, negative 2. What'd you get for the second row?
0, 1, 0, negative 1.
What'd you get for the third?
0, 0, 1, negative 2.
And you probably got all zeros for the fourth, or
Yeah.
at least you should have. Because for any chemical equation, it should always be zeros on the bottom. Okay. So then you just read it off. What should I let? Again, now, by the way, A, B, and C are our pivot columns, and then D is our free variable. Hopefully you're all clear with that. And what should we let our free variable be?
Just 1.
Yeah, just 1. So then we get, I'll just write as a vector. We get 2, 1, 2, 1. And that means if we want to write down as a chemical equation, those are going to be the coefficients. So A is 2. B is 1. C is 2. And D is 1. I know the 1's a little redundant, but it just kind of shows what happened. Any questions? Any questions on this chemical reaction example? Okay. Note, I want to remind you, if you have fractions in the fourth column, then you let the free variable be the least common multiple. Okay, or the greatest common divisor, I guess I should say. Least common multiple of the denominators is what I want. Any questions at all? Did that help out? Okay, so that was chemical equation balancing. Okay, again, easy to come up with because I can go online and find one. And there's hundreds of them online. That's the good news. There's a lot of chemical equations. Okay, what else would you like to see? That's what I'm doing today, by the way. I'm just opening it up to see, we're going to do problems. We're going to do examples. Some I can come up with off the top of my head. Some I can look online. And I do want to let you know there's one question on the final that is without calculator. All the rest are with calculator. I want to kind of keep it consistent with what you've seen before. I'd say computer instead of calculator, though. Any questions or any requests? Maybe I'll show you the big list again.
We'll go over Fibonacci numbers again.
Okay. Do you want Fibonacci or do you want a variant of Fibonacci?
I guess just the variant of Fibonacci, since it sounds like it builds on it more. So
yeah, it'll be the same idea as Fibonacci, but let's do a variant. So suppose, what's your favorite animal?
Otters.
Okay. In a lake. Wait, I guess they're in oceans, right? In a bay.
They're both freshwater and saltwater, so either one.
Okay,
works.
good. I'll make it a lake then. I don't know otters well, but I know what they look like, but I don't know anything about what an otter does. So suppose in a lake there is one. Actually, let's go. There are 3 female otters. Okay. It takes there are 3 female otters. Let me do a little more. 2 that were born today. And 1 that gave birth. Okay. It takes 3 months. Let's go 2 months to make it better. For a newborn otter to give birth. Because they got to get old enough and they have to have sex and then give birth. Okay. And when they do, they have 2 female otters, otter babies. There might be a word for otter babies. I don't know what it is, so just call them otter babies. Okay. Any questions so far? All right. So the question is, if pups sounds good. Okay, so I'll make them pups. Okay, so if no otters die this year, actually over the next 12 months, how many otters will there be in 12 months? Okay, and I wanted to let you know I'm totally making up this question. I actually have no idea how many babies otters have and how long it takes them to get old enough to give birth. So please don't, quote me on any of this information. But Fibonacci-like problem is what you wanted. Does it sound like Fibonacci?
Yep.
Yep. Okay, although it's not rabbits, it's otters. Shouldn't make any difference though. All right, let's see if you can, and again, what you want to do is you want to come up with the matrix. It's always about the matrix, but it's going to take some work to get to that matrix. See if you can come up with it. So I'll give you a couple minutes. And then, so that this is going to be a kind of a 2 big step problem. First is come up with a matrix, and then second is answer the question. So you don't need to answer the question right now. Right now, I just want to make sure you can come up with a matrix that will get us there. Sometimes they call this the discrete difference equation. There's lots of words for this kind of matrix. And if you need help, you can always ask too, if you're just stuck.
Yeah, I'm kind of having trouble finding a matrix. I've always been kind of confused by these Fibonacci problems, honestly.
Okay, so the first step, and maybe some of the rest of you are getting it. Anyone want to answer what the first step is?
Write out a system of equations.
Yeah, and what's the first equation we write out for something like this? Hint is recursion. Do you remember how that works?
Maybe the initial population equals the variable.
Okay, you could do that. I was going to do that last, but you can do that first if you want. So we want the initial population, and we need a letter. Do you want to use X? Sound good?
No.
So we know that X naught is equal to, yeah, I think it's a little early to write the initial. Because we know what the X naught is in terms of the initial population, right? But we probably don't want to do that yet. I think you don't want to start with the initial. Let's do that last in terms of the write-up. So instead of X naught, what I'm going to write is X n plus 2. Right? Where n plus 2 means 2 months later. Well, what is xn plus 2 going to be? Any ideas? Okay, well, how is this going to work? Well, if you want to find 2 months later how many you're going to have, it's related to how many you used to have that are young, right? And how many you have that originally were just there. Does that make sense? So notice that you're going to have.
Would it be 2 multiplied by x of n?
Yeah, it's going to be 2 x sub n, because that is going to be how many you had 2 cycles ago, right? But there's going to be more going on, right? What else?
Accounting for the new ones that were born.
So we've got, so the 2x of n's are going to be twice what we had then. But also, we're going to add that to what we previously had. And that's x sub n plus 1. Are you following where that comes from? Any questions on that? Okay, and that's true because what you can do is you can say, well, you're going to have all the adult ones, okay, at least 1 month old. Those are going to be the x of n plus 1s. And then you're going to have all the newborns, and the newborns are going to be twice x of n. Anyone lost on that, or are you following? Okay, then comes some tricks. And I usually like to write on top. Let me write it this way. Oops. X sub n plus 1 is equal to, I know this is stupid, but it helps to write it, x sub n plus 1. Ah. That will work. Nope, won't work. Let's try it that way. There we go. Any questions on that idea? Why did I do that? Any thoughts?
Maybe so we have enough rows for the matrix to be square.
Yeah, we need a matrix. Otherwise, we're not going to get a matrix out of this. So we know x of n plus 1 is x of n plus 1. I don't think I need to do anything to convince you that, right? Okay. How many variables do I have here? Right, I have 3. So let's do x of n.
Yeah, 3.
X of n equals x of n. Any questions on that? Okay, so we know all of this, and now we can write down a matrix. Any questions on that? Okay, in fact, I think I don't need the second, I need the first one. I just need the second one, if I remember right. So now how does the matrix go? So let's
Put everything on the same side of the equation first, and then right?
No, you don't need that. Here's what we do need, though. What we need is a matrix. And I'm going to write it as the vector matrix. X of n plus 1, x of n plus 2. is equal to the matrix, the 2 by 2 matrix. And that 2 by 2 matrix is going to be 0, 1, 2, 1. Times the vector x sub n plus 1. That was a 2, not a 1. So the matrix is 0, 1, 2, 1. Anyone lost on that? Hopefully, if you can, in your head, multiply that matrix times a vector and realize you get what you're supposed to get. Is there any questions on that? Because that's the coefficient matrix. If I want to find out what it's going to be in 12 months, what do I do?
Just take the matrix to a power of 12.
Yeah. So I'm going to take the matrix to the power of 12. And now I'm going to get x sub. Actually, I need to make it 11 is enough because that'll get my x plus n plus 12, right? Because if you start out with n equals at the beginning and you add 11 to it, if n is 1, you add 11 to it, you get 12. Does that make sense? It depends whether you call this month 1 or month 0. So maybe I'll go 12 to me. So we'll call this month 0. Okay, and then that'll be n sub. Let's see if this is month 0. No, I only need 12. I need 11. Because I don't need to know about the 13th. And then we'll get x sub n plus 11 and x sub n plus 12. Any questions on that? Is this kind of what you wanted to see?
Yeah, it's perfect. Thank you.
Yeah. And then, I mean, you could take it to the 11th power. That's a lot of work. But if it was a much higher power and you had to do it with, efficiency, you would diagonalize it. And then remember, when you diagonalize it, then you can write P inverse times D to the 11th times P. And D to the 11th is easy, right? A diagonal matrix to the 11th is easy. And multiplying by a single P and a single P inverse is not that hard either. Any questions on that? Okay, what else would you like to see? Let me scroll up again to our list. So I'm taking requests. First request, we'll do it. And I do want to remind you, there's only going to be, I think, one application problem. So, don't just have me do, I could do all application problems, but that only gets you ready for one problem on the test. So what would you like to see?
Can we go again how to came up with a matrix for a vector space?
So a matrix for a vector, you mean a linear transformation?
Yeah.
Okay. Yeah, so a vector space doesn't have a matrix, but a linear transformation has a matrix. Does that make sense? Right? Okay, so let's do that. They're easy to make up. Do you want it? I'm going to give you two choices, and you need to know how to do both. One is when the vector space that the linear transformations go from are just Rn or Rm, and the other is when they are general vector spaces. What would you like to see? Victor?
For well, we can go for the one that converts a linear transformation to the derivative.
Okay, so you want to see general.
Yeah.
If it's got a derivative, then that's general. Okay, so you want to do the derivative? Okay, so let's so we'll just do the derivative function. All right, I'll let you choose. P what? Or would you, yeah, so do you want to, we could do P something, or we could do sines and cosines, or E's. You choose.
P3 sounds good.
P3 it is. Okay, so consider the linear transformation from P3. I'm gonna let you choose one more thing in a second. Do you want it to go to P3 or P2? You choose.
P2.
P2. And maybe I'll call it T for linear transformation, defined by T of F equals F prime. That's kind of what you want to see?
Yeah.
Let a basis for P3 be, now I'm going to make one up. How about x cubed? How about x squared? Comma, x cubed minus 1, comma. How about x plus 1, comma. By the way, how many do I need for P3 to be a basis?
We need 4.
I need 4. So I'm almost there. Okay. Hopefully I'll really be a basis. Okay. So x squared, x cubed plus 1, x plus 1. And how about x cubed plus 2x squared? Oops. Put that on a line. And then I want to just double check it. Yeah, that works. And a basis for P2 is x comma x squared plus 2, comma, and for P2, I need 3 of them, comma 1 minus x. That should work, I believe. Yeah, it's got it. Let me triple check. Yeah, that works. Find the matrix for T with respect to these bases. Is that kind of what you wanted to see, Victor?
Yeah.
Okay, so let me give you a few minutes. Let's see how far you can get. And let me know when you've got at least got it set up so that you could put it in a symbol lab and get it at that point. Because the main thing is the setup. That's where the big points are. And if you have questions, I can help you. And it might even be helpful just for when I'm explaining it. Let's give them letters. Let's call the first basis, how about B? And how about the second basis, call it C? I don't like to use A because those are from matrices. And again, let me know if you need help or if you've got it. And this is one of those, you don't have to write in all the numbers if you got it. Just say you got it, or at least you think you have it. Because the numbers are a bit messy because I just made this up.
I'm not sure how to write the matrix for the basis of P3.
Okay, so you want to see my first step?
Yeah.
Because I think that helps. So the first step is to write down the following. B goes to, actually, let's not B, maybe P sub 2 sub B. It's P3, sorry. Goes to P3 sub E for standard. Goes to P2 sub E. Goes to P2 sub C. Last. Try this again. There we go. Do you understand the diagram?
Yeah.
And you want the matrix with the first arrow. So you actually have two choices. You could choose descending or ascending. Does that make sense? For E.
Yeah.
That's totally up to you. I think I'm going to use descending because I wrote these in descending order. Sound good? Okay, because you'll get actually a different set of matrices for ascending than if you do for descending, but your answer at the end will be the same. So let's look at the first matrix. Okay. So I'm just going to look at the first matrix. And that goes from P3 with respect to the B basis to E. Any questions on that? So it's much easier than you're making it, I promise. So all you do is you write down a matrix. This is a P3, so it's going to be a 4x4 matrix. Because it's P3 is 4-dimensional. Oops, I'm going to go here. And what you do is you just say, okay, look at that first vector, x. First vector x squared. X squared is 0, 1, 0, 0. Is that clear, Victor?
Yeah.
So I just do 0, 1, 0, 0. Any questions on that?
No.
How about x cubed minus 1? What's that going to be?
That will be 0, 0, 1, 0.
Yeah, it's going to be 1. So we have an x. The second one has an x cubed, right? Do you see that?
Yeah.
So it's going to be 1.
Yeah, this is descending, right?
Yeah, 0, 0. You got to choose. I could have done ascending, but you got to be consistent. Once you've decided, you can't change your mind. Is that clear? Okay, and then what's the third one going to be? The third column.
0, 0, 1, 1.
Whoops. And how about the fourth column?
That's 1, 2, and 0, 0.
Was that easy?
Yeah.
Okay. Hopefully all of you, maybe at this point, have the other matrices. Let's do the T matrix. So it's T in standard basis. Okay, what are the dimensions? What are the dimensions of T going to be? It's a what by what matrix?
Would it be 4x3?
Yeah, it's 4x3 because you're going from P3 to P2, dimension 4 to dimension 3. So let me double check that. No, sorry, 3x4. My mistake is always to just say yes, but it's 3x4 because remember you switch the letters, right? So it's 3x4. And the way I like to think about it, just to make sure I get it, is T is going to take something in something in P3. So if it's going to take something in P3, that means you multiply it by something in P3. If you multiply it by something in P3 that has 4 things in it, then it has to have 4 columns for that dot product to work. Okay, so then you go ahead, say, what is T of x cubed? Our first basis vector. What's T of x cubed?
It will be 2x or 2, 0, 0.
Yeah, so, well, T of x cubed, not 2, 0, 0. What's the derivative of x cubed?
2x or 3x squared.
It's 3x squared. So it'll be 3, 0, 0. Is that clear?
Yeah.
Okay. What's t of x squared?
Two x.
Right. It's 2x. So how to write that as a vector?
0, 0, 2.
0, 0, 2 would just be 2. We want 2x.
0, 2, 0.
0, 2, 0. Let me know if you're not understanding any pieces of this. Okay, how about t of x?
Just 1.
Right, but as a vector?
0, 0, 1.
0, 0, 1. Oops, 0, 0, 1. And how about t of 1?
All zeros.
Yeah, 0, 0, 0. Okay, so there's t in the standard basis. Now we want third matrix. So we want to go from P2E to P2C. Is that clear? So the idea is not supposed to be hard. Hardest part is typing. That always takes time. The good news is you don't have to type for the exam. I do. Okay. And what's the first column going to be?
2, 0, 0.
Okay, so what we're looking at is we're going from standard basis to C basis. Here's our C basis. That's a hint. So what's the first column going to be? Nothing to do with T here. Right? The first component of this, yeah, 0, 1, 0, because the first basis vector is x. X is 0x squared plus 1x plus 0. So it's going to be 0, 1, 0. Okay. How about the second column? What's it going to be?
1, 0, 2.
How about the third column?
0, negative 1, 1.
Any questions on that? Okay, now we got to put them together. And I want to remind you with functions, the arrows you read from left to right, but you put them from right to left, right? Because they're functions. So what I'm going to do is I'm going to first do the first arrow, first matrix. Then I'm going to do the second matrix, but I need to do that on the right. Sorry, on the left. Then I'm going to do the third matrix on the left, but what do I have to do? Why is that not right yet? There's one last thing I have to put in. Yeah, inverse. And then that's going to be my matrix. Okay, and then I'm not going to waste your time, but I'm assuming you know how to put that in Symbolab, right? Or whatever computer program you like.
Yeah.
Does that totally make sense, what happened here? Or did I lose you somewhere along the line? Okay, nothing we haven't done before. And we haven't done this exact example, of course, but isn't the middle one BT right? I'm not sure what you're asking. Sorry, I can't. I'm reading it and I don't know what that says. Isn't the middle one BT right? I mean, transpose matrix. No transpose. Yeah, definitely no transpose when you're doing change of basis. In fact, if we did transpose, this wouldn't work because you couldn't multiply. Notice that the middle one is a 3 by 4, and the right one is a 4 by 4. So if you did the transpose, you'd end up with a 4/3 times a 4/4, and that doesn't work. Because you have to have the second bi be equal to the first bi of the other one. That means anything to you. Does that make sense? So this is the answer. Any questions at all on this example? Okay, let me go back up to our list of topics. What else would you like to see? Maybe I'll mention something, a few things. If you want to show something as a linear transformation, what do you write in general? I'm sorry, not what two things do you have to show?
Shows under addition and scalar multiplication.
Yeah, T of V plus W is T of V plus T of W, and T of KV equals KT of V. Just going to go through each of these things. Okay, linear independence. What's the equation you write down if you want to show they're linearly independent or dependent?
C1 plus V1 plus CK times VK equals 0.
Perfect, except for your first symbol. It's C1 V1, not plus V1. So it's C1 V1 plus ... plus CK VK equals 0. That might be what you meant. Is that?
Yes, it was.
Yeah. Okay. Change basis, we just did that example. Kernel, how do you find the kernel?
So I actually had a question about that. The way you find if vectors or whatever you're looking at is linearly independent, isn't it the same as finding the kernel of something?
No, linear dependent is a yes/no question.
Okay.
Right? You go C1 V1 plus ... CK VK equals 0, and you need to end up with C1 equals ... CK equals 0. It's definitely not the same as finding the kernel. Finding the kernel, since I asked how do you find the kernel, means that you say T of V equals 0 and prove that V equals 0. Okay, if you end up with a matrix, then you show if you want to find the null space so that's to find out if it's 1-to-1, but to find the kernel, then you turn it into a matrix typically, and then say what is the null space of the matrix, and the null space of the matrix will be the kernel. Any questions on that?
No, that makes sense.
Okay, how do you find the image?
They are all vectors in W that
get hit. That's the definition, but the way you find it is you take a basis for, if you can, you take a basis for the domain, and then you take the linear transformation of that basis. So you can have a bunch of vectors, T of V1 ... T of VK. And then what you're going to do is you're going to find a basis for T of V1 through T of VK. Usually you're going to pop into a matrix, and then you're going to use your, you're going to RREF it, and then you're going to say the pivots. The pivot, you take the pivots, and you say that the columns that you made a pivot out of, that's your basis. I don't know if you remember, but that's how you did basis. And that's how you do image. How do you find the nullity?
Isn't that the dimension of the kernel?
Yeah, it's the dimension of the kernel. And the process is you turn it into a matrix, you RREF the matrix, and then you count the number of free variables, and that's your nullity. Any questions on that? Again, if I'm saying something you don't understand, please ask. That's the whole point. How do you find the rank?
Typically, you RREF matrix and the number of pivot columns is your rank.
Good. Good. So if it's a linear transformation, then you find your number of pivot columns, you turn to a matrix, find the number of pivot columns, and that's your rank. Okay, what do you have to show something is a subspace?
It's the vectors are linearly independent.
Nope, you don't have to have that.
The zero vector is in the subspace.
Okay, that's one of it. So one of them is the zero vectors in it. There's two more things.
Then we let two vectors be in the subspace, and the addition of them is in the subspace too.
Yep. If V1 and V2 are in V, then you got to make sure that V1 plus V2 is in V. And then the third?
The scalar multiplication is in the subspace too.
Right. KV needs to be in our vector space V. Okay, so you show those three things. Okay, how do you find the span?
We need to find a basis for a matrix.
Okay, so when you say find a basis, so you have a bunch of vectors. How do you show, no, I shouldn't say how do you find the span. How do you show that vectors span a vector space is what I should say.
We RREF a matrix, and depending on the number of pivots, then if there's a free variable, it's a dependent set.
Yeah, if you can do that, but what's the equation you write down to show something's in the span? That was C1 V1 plus dot 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 plus CK VK is equal to the vector that you're interested to see if it's in the span or not, is equal to V. And if you can find constants C1 through CK that work, then it's in the span. Do you remember doing that? Okay, and if you can do a matrix out of it, then you're right with the matrix. Then you just make sure that you don't have a 0 equals 1 based on the matrix, or 0 equals some non-zero number based on the matrix equation. Okay, so I figured I should probably go over each of these and what you do. TFEE is a long story. I'm not going to ask you to write down, everything in TFEE, but you should know how to use TFEE if you need to. Okay, or when you need to. How do you do Gram-Schmidt? Because that's orthogonality.
There's a formula.
Mm-hmm.
I don't really know it off the top of my head, though.
Good. There is a formula. There's a formula. You take your vector, your next vector, minus that vector dotted with each of the vectors divided by the magnitude of each of those vectors. Subtract each of those guys, and that's your new vector. And then at the very end, you divide by the magnitude. So that's the formula.
I have a quick question.
Mm-hmm.
What's the difference between formula and algorithm?
So an algorithm is a step-by-step process. Like follow these 12 steps. That's an algorithm. Does that make sense?
Yeah.
A formula is an equation to solve something. So for example, the quadratic formula, negative b plus minus squared b squared minus 4ac all over 2a, right? That's a formula. Is that clear?
Yes.
Okay, but factoring is more of an algorithm, right? Use the AC method. That's an algorithm. Do you remember the AC method for factoring?
Yeah, that makes sense.
There's no formula for the AC method, is there?
Not that I'm aware of.
No. So that's the big difference, is that there's a formula means really you have an equation, put that equation in, and that's what you get. Whereas algorithm is follow these 5 steps and you'll get there. That's the difference. You're not responsible for that. I won't ask you that question. What's the difference? But if you ask it, if you ask it in class, I'll always answer if I can. Any questions on any of these types? So we have a few minutes left. I could still do one if you want to see one of these done, of the ones I just kind of mentioned, which was all of them. I'm seeing 2:41 on my clock, so we do have some minutes, but And if we want to leave a few minutes early, we can do that too. That's your choice. I'll be in office hours if we leave though, but I'd be happy to do an example. And I want to remind you, make sure that you don't miss Monday. Okay, you need to be there, live to present. It's a live presentation. It's up to you whether you want it to be recorded or not, but you have to actually do it. And so that's really important. And make sure that so a big suggestion I have is you and your partners should present it on Zoom, okay, or something like that, Skype or whatever you've got, to each other, you know what I mean, before you do it to everyone. So it's always a good idea to do a dress rehearsal before you do the performance. Does that make sense? That's a suggestion for presentations. Don't just say, oh yeah, we know what to do. Try doing it. Make sure it lasts around 20 minutes, 15 is okay. 5 is not okay. Does that make sense? Then you didn't do enough detail. Okay, and again, you could always do more than one example. You can do multiple examples if you want to kill some more time. Any questions about anything in the next couple minutes?
So that homework problem number 4 that we did earlier, where we got imaginary numbers for our rotational matrix, what does that mean in reality?
I think I'm not even going to go there. It's a complex rotation in a 4-dimensional complex space or 4-dimensional real space with the 2-dimensional complex numbers. So that's about all I'll tell you. Is it ever used? Yes, but I think it's too advanced for me to explain in the 2 minutes left. Sorry about that.
That's all right.
Yeah. Typically what you're interested in the real world is you do this and then you do the real component of it. But that's not something I can do in 120 seconds. Sorry about that. But you can do complex rotations. Other questions? I don't know if I have time to do a whole problem anymore, but I can answer. If you want, we can stop share and I can do that kind of questions over last minute. Any questions about anything? Okay, I think I'll call it a last lecture because again, Monday is your lecture, not my lecture. I'm gonna be listening and hit stop recording.